Okay, this video has got answers to students' questions, and we're going to start with a question about gradient. So here we've got the meaning of gradient in a distance-time graph. Gradient is actually the speed. So this line here, the gradient's 1 kilometre per minute, or 60 kilometres per hour. The rise is 10 km and the run is 10 minutes. So if we go from here to here in 10 minutes, it went up 10 kilometres. So that's 1 kilometre per metre. This one here, we have got a gradient of 0.5 kilometres per minute. The rise is 10 and the run is 20. So in 20 minutes we went up 10 kilometres. This one here, we've got a gradient of 0.1 kilometres per minute. Now I'm going to change this graph, line D, object properties. So line D, I'm going to go plus 2 to that graph. So what's happened is I've actually haven't changed the gradient at all, but I've changed the y-intercept. So what would that mean in real life, that y-intercept? If this here is time and this is distance, and they're going from A to B, where did the blue person start? 2 kilometres away from the starting point. They had a bit of a head start. Why would you give that person a head start? Because they're slow. Let's imagine that the race ends, I don't know, the race is going to end somewhere around here. What could we do to this person to give them a bit of a handicap in the race? Start them behind the start line by how many kilometres? Shall I try 5 and see what happens? Okay, so I've actually put them further down. I could put them right down there, so they're starting way behind the start line type thing. I'm going to move them back. What's the y-intercept of the green one? What's this y-intercept? It starts at 4 kilometres, correct. Okay, if I change this and instead of have 0.5 I go 0.05, what have I done to the gradient? What's happened to the gradient? Yeah, so we're 0.05 kilometres per minute now. Is that making sense? Yeah? So, what have we learned? When you have a distance time graph, the gradient is speed. Now I'm going to do something different. New window. I won't save that. And I'll just pause for a minute. Now moving on to this one here, I'm going to try and draw a graph to do with taxi charges. And we're looking at minutes on the x-axis and the cost of the taxi on the y-axis. If I said y equals x, then I would just be charging $1 a minute. Okay, so for every minute, you would be charging $1. If I said y equals 0.5x, then for every 2 minutes, I'd be charging $1. If I said y equals x plus 5, I'd say you actually pay $5, so I'm just going to highlight this one, make it a bit fatter. So here I'll just want to print all over it. So let's go back into here. Okay. So what I'm saying here is that minutes is here, and what you get charged is up here. So this one here, the equation of this line, that's got a y-intercept of 5, and for every 1 minute that way, we get charged 1 minute. So that was y equaled x plus 5. Does that make sense? Let's go back here and object properties, x plus 5. I changed that to 2x plus 5. Then what's our y-intercept? What's our y-intercept? 5. 5 is the y-intercept, and what's our gradient now? Here we have it. I had the same graph. So our y-intercept is still 5, y-intercept of 5, but the gradient, if I go across 1, I have to go up 2. So for every 1 minute, there's $2. So it's $2 per minute. So that's my minutes charge. So y equals 2x plus 5. That's my standard charge for getting into the taxi. This is my rate, $2 per minute. So what if I wanted to charge $2 per minute, but I'm going to have a standard charge of $10? What do I do? Yeah, so 10, whoops, no, hang on. We're going to have $2 per minute, and I'm talking about standard charge. So hang on. Okay, M is the gradient. So here we have, we have a gradient of a half, a gradient of 1, a gradient of 2, a gradient of 3. Oh, sorry, saying the wrong thing. But here you can see that the gradient is the number in front of the x. This C, whoops, I'll move that down out the way. What gradient should we have? We'll leave it like that. This one here, the C, or can you relate it to this number here, plus 7? It's gone off the thing. That here's the 1, there's the 1 here. So this number here is the number that's the y-intercept, and the number in front of the x. So let's just look at that for a minute. What I've got there is an M and a C, and this equation is y equals whatever M is, x plus C. Okay, so whatever C is, that's the y-intercept, and whatever M is, that's the gradient. So for every 1 across, it's going 0.5 up. Is that making sense? Yeah? So we know what gradient is. So if we go back, let's change this taxi guy. So if I said he's got to have a rate of $3 per hour and an initial charge of $5. Okay, so we'll pop that one there and make it red and fat. Okay, so now I'm going to get rid of that one, so I just delete, and I want to talk about this. Okay, so we're just looking at this yet again. What's our y-intercept of this one here? That's actually 2, 4. So that y-intercept there is 5, and this one, although it's written a bit strange, it's actually 10. Okay, so that's the y-intercepts. What's the gradient of the red one? Go across 1, we go up 1, 2, 3. Is that right? So what's this one? Equation of the line? Y equals 3x plus hang on, 1, 2, 3, 4, 5. 3x plus 5, and then this one, the equation is y equals, we go across 1, we go up 2, across 1, up 2, 2x plus the y-intercept of 10. What does the 2 mean? It means $2 per minute. What does the 3 mean? It means $3 per minute. So this one here has got a steeper slope. Okay, the red one's got a steeper slope, so it's got a greater hourly charge. This one here with the 10 has got a larger base rate, the charge for getting into the taxi. At what point are the two taxi charging companies, let's call that company A and company B, at what point do they charge the same amount? What happens here? What's on this axis? Minutes. What's on this axis? Dollars. So what's happening at 5 minutes? What does company A charge? Let's actually put our, let's try 5 minutes in there. Oh, the other thing we can do is we can go 2x plus 10 equals 3x plus 5. Therefore, negative x equals negative 5, or x equals 5. So we can use algebra to actually work out, yes, definitely, the crossover is when x equals 5. So in a sentence, company A and company B charge the exact same amount if you spend 5 minutes in the taxi. And that amount would be 3 5s are 15 plus 5 is 20. Okay, there's our 20. And 2 times 5 is 10 plus 10 is 20. So both companies charge $20 for 5 minutes in the taxi. Company B is cheaper than company A because the line is below this one. If you are in the taxi for less than 10 minutes. Company A is cheaper than company B if you are in the taxi for longer than 10 minutes. So that's already excellent if you can see that and talk about that. Okay, so we have got gradient. The gradients of the line represent the charge per minute. And the other thing is, if you think of rise upon run, you think of dollars per minute. So the gradient is the dollars per minute. The y-intercept is the standard charge. At 0 time, you have to pay that just for being in the taxi. Then we talked about the fact that you have got two lines, they intersect at a point, and what does that intersection mean? At that point,